Welcome to Module 3. This module is going to cover measures. We're going to go over counts, proportions, ratios, and rates. At this point in time, we've covered a great overview of epidemiology. We've gone over what it is, the history of epidemiology, and the tools used by epidemiologists. As was mentioned many times, when epidemiologists collect data, they analyze this data. We're now going to begin a large section of the course devoted to data. In fact, the next two modules, Module 3, this one, and Module 4 will cover measures of occurrence or frequency. These modules will slow down a bit because they are math heavy, and it's very important that you become comfortable with these measures, how to create them, what they mean, and how to analyze them. Please take the necessary time to familiarize yourself with these concepts by doing the practice questions. From this module forward, we will be learning how to calculate many different epidemiological measures, and then all about different types of studies. If you fall behind, you will have trouble catching up, so please reach out to me and your other instructors. So as we know, public health questions are about populations, and information about population characteristics is often summarized. Changes in population characteristics can be assessed by comparing two different summary measures. And there are two different types of summary measures. There are measures of central tendency, which will not be covered in this course, and then measures of frequency, which we're going to start talking about now. The pre-reading that you may or may not have done for this class was Lesson 2 of the CDC Introduction to Epidemiology Self-Study book, and in this was a description of measures of central tendency. If you're not familiar with these measures of central location and spread, you may want to review that lesson. Measures of central tendency are useful for summarizing continuous variables and include things like median and mean. However, many variables used by epidemiologists are categorical, some of which that only have two categories. Things like whether someone was exposed, yes or no, what the result of a test was, positive or negative, whether an individual is a case or a control, and so on. And these variables have to be summarized with frequency measures. Frequency measures that we're going to discuss are counts, ratios, proportions, and rates. Just to reiterate, a measure of central location provides a single value that summarizes an entire distribution of data. In contrast, a frequency measure can characterize only one part of the distribution. So, we're usually interested in looking at the frequency of health events. Frequency measures compare one part of the distribution to another part of the distribution, or to the entire distribution. The most commonly used measures for assessing frequency are counts, ratios, proportions, which could also include percents, and rates. And these measures can actually be used with both continuous and categorical data. So counts are the simplest measure of frequency. A count is just the actual number of health events in the population of interest. Counts are commonly used for program planning to gauge the magnitude of the problem and for the identification of rare or, in technical terms, sentinel and severe events. These rare or severe events should trigger action even though the number of cases is small. For example, the first case in a specific area of West Nile virus or a case of measles. The use of only counts has several limitations, however. Counting events or cases does not give an indication of the problem in relation to the size of the population. For example, 10 cases of influenza. 10 cases of influenza in a school population of 50 students is a greater public health concern than 10 cases in a student population of 500. And also, the use of counts alone does not provide any information on the risks associated with having the event or the disease. Ratios are common descriptive measures used in all fields. In epidemiology, ratios are used as both descriptive measures and as analytical tools. As a descriptive measure, ratios can describe the male to female ratio of participants in a study, or the ratio of controls to cases, like 2 controls per case. As an analytical tool, ratios can be used to calculate for the occurrence of illness, injury, or death between two groups. These ratio measures, which will include a risk ratio, relative risk, rate ratio, odds ratio, are going to be covered later on in this class, and we'll get to know them quite well. The numerators and denominators of ratios can be related or unrelated. In other words, you're free to use a ratio to compare the number of males in a population with the number of females, or to compare the number of residents in a population with the number of hospitals or dollars spent on over-the-counter medicines. Therefore, a ratio can compare two dissimilar things by dividing one quantity by another. For example, say a group of people has 5 women and 7 men. The ratio of women to men is 5 to 7. A ratio is also a general term for rates or proportions. Ratios are used in public health to identify disparities. An example of this would be an analysis of infant mortality by race. In King County, for the combined years of 2002 through 2006, infant mortality among American Indians and Alaskan Natives was 14 per 1,000 births, whereas it was 4 per 1,000 births for whites. This is a ratio of 3 to 1, or 3 times the infant mortality for American Indians and Alaskan Natives compared to whites in King County. Proportions are common descriptive measures used in all fields as well. In epidemiology, proportions are used most often as descriptive measures. For example, one could calculate the proportion of persons enrolled in a study among all those eligible, i.e., the participation rate, or the proportion of children in a village vaccinated against measles, or the proportion of persons who developed illness among all passengers of a cruise ship. Proportions are also used to describe the amount of disease that can be attributed to a particular exposure. For example, on the basis of studies of smoking and lung cancer, public health officials have estimated that greater than 90% of the lung cancer cases that occur are attributable to cigarette smoke. In a proportion, the numerator must be included in the denominator. Thus, the number of apples divided by the number of oranges is not a proportion. But the number of apples divided by the total number of fruits of all kinds is a proportion. Remember, the numerator is always a subset of the denominator. A proportion can be expressed as a fraction, a decimal, or even a percentage. The statements 1/5 of residents became ill and 20% of residents became ill are equivalent. Before we go on to look at rates, I want to discuss a term you'll hear often in assessing community health. That term is persons at risk. Persons at risk are the people in the total population, or in other words, the denominator, to whom the event or health condition being studied could have happened. Usually this is everyone living in a specific geographic area during a time period of interest. But under certain conditions, however, we need to exclude some persons from the total population. For example, when looking at prostate cancer, we would exclude women. To a non-epidemiologist, rate means how fast something is happening or going. The speedometer of a car indicates the car's speed or rate of travel in miles or kilometers per hour. The rate is always reported per some unit of time, and that's something to keep in mind. In epidemiology, a rate is a measure of the frequency with which an event occurs in a defined population over a specified period of time. Because rates put disease frequency in the perspective of the size of the population, rates are particularly useful for comparing disease frequency in different locations at different times or among different groups of people with potentially different sized populations. That is, a rate can actually be a measure of risk. We generally use rates to estimate risk, and risk, as used by epidemiologists, is the probability or likelihood that an event will occur. For example, the likelihood that an individual will become ill or will die within a stated period of time. Rates, again, measure events in relation to the size of the population in which they occurred in a specific time and place, the population at risk. Rates allow us to compare the risk of a health event across different groups of people, places, and times. And rates help us describe the burden of disease or other health events in a population over time. So let's look at an example to help clarify the concept of rates. Here's a table showing hepatitis A cases in 2 Washington counties from 1999 through 2001. There are 31 cases in Cowlitz County and 32 cases in Spokane County. So, looking at this, some of the questions we might ask are, where is the risk of hepatitis A higher? Is this a lot of cases? And what other information do we need? Although the absolute count of hepatitis A cases is higher in Spokane, what we really want to know is if there is a disproportionately more cases in Spokane than in Cowlitz County. And to answer that question, we need to determine the population at risk and then calculate the rates for each county. So, how do we calculate the rates? So you calculate a rate by taking the number of persons experiencing an event, such as hepatitis A, hospitalization, death, or birth, and dividing that number by the number of persons at risk of experiencing that condition. Remember, the persons at risk refers to the people in the total population to whom the event or health condition we're studying could have happened. When calculating a rate, both the numerator and the denominator must represent the same time period and place. So the persons experiencing the event and the persons at risk of experiencing that condition must come from the same time period and the same place. We express rates in terms of standard units of population to make comparisons easier. For example, 37.3 per 100,000 population is easier to read and discuss than 0.000373. The standard unit of population that you use when you calculate a rate is based on convention. So again, let's look at our hepatitis A case example. Hepatitis A cases in Cowlitz and Spokane counties and all the questions that we asked before were, where is the risk of hepatitis A higher? What other information is needed? So to answer those questions, we've added some additional information about the total population in those counties. Notice that although we're now using 2 different sources of data, case counts and population data, we still must use the same time period for each. By using our formula to calculate a rate in each county, we can see that the rate of hepatitis A was higher in Cowlitz County than in Spokane County. So we can say that in this time period, the risk of hepatitis A was higher in Cowlitz County. I would suggest that you look over these numbers and make sure that you can recreate the numbers that are seen in the column that's all the way to the right. So, an important concept that came out in that last example was the concept of person time. As you'll notice, our hepatitis A cases were described as an average annual rate per 100,000 people years. So this is a very important concept that we must wrap our heads around. Individuals may be exposed to the risk of an event for varying amounts of time during a total time period of a certain length due to things like entering the time period later, leaving the time period earlier, or when they experienced the event of interest. So person time is a calculation combining the people and the time. It's the sum of the individual units of time that person has been exposed to the risk of an event. And then this is used in the denominator of person time rates. And it's very important in both epidemiology and vital statistics. Now, to illustrate this and understand this a little better, let's look at an example. So in our example of person time, we're going to look at an example of person years. So suppose that during a 2-year period of time, there were 10 episodes of diarrhea at a daycare center. There are 35 children that attend that daycare center. And if we look at those 35 children who came and went at different times, there are different fractions for each child. So for varying fractions of the 2-year period, we have a total of 50 child years. So to figure out the rate, we would look at those 10 diarrhea episodes over the period of 50 child years of observation. This would give us 0.2 episodes per child year. There are many different types of rates that you will come across as you go through your epidemiology career. And this slide is showing you some of the different rates that we will see in this course. Two of the rates that are seen in vital statistics can be examined further to distinguish between rates and proportions. That is infant mortality rate and fertility rate. So infant mortality rate is the number of infant deaths per 1,000 live births during a calendar year. This is a ratio. It's not a proportion because the numerator is not necessarily part of the denominator. Some of the infants may have been born. Some of the infants that died may have been born during the previous calendar year. In contrast, fertility rate, which is the number of live births per 1,000 women aged 15 to 44 during a calendar year, is both a ratio and a proportion. Okay, so in summary, in Module 3, we've covered measures of frequency. We've learned how to summarize data as counts, ratios, proportions, and rates. We've covered the concept of person time, and we've briefly touched upon commonly used rates. Before moving on, it's really important that you make sure you understand the differences between these different summarization methods and how to calculate them. I would definitely recommend doing the practice problems and reaching out to myself or any of your instructors if you're having trouble at this point in time. Knowing how to manipulate these numbers is going to be really key in some of the other risk summaries that we're going to go over in some of the future lectures. In Module 4, we're going to cover different measures of frequency, which include incidence and prevalence rate.